Hello, everyone, and greetings once again. This is again a continuation of the fifth unit of the Basics of Aeronautical Engineering. It's an open elective, and I am Dr. Ilangovan, Professor, Department of Aerospace Engineering. This is intended for my students who are pursuing their open elective course on Basics on Aircraft Engineering in their third year. Sorry. Now, in this video, we'll talk about the Mach meters, right? Okay. What are Mach meters and limitations of this calibrated airspeed? What really happens at a high speed? The the calibrated airspeed becomes inaccurate at high speeds and altitudes due to air compressibility. As the air molecules get compressed, the pitot tube used for the CAS measurement provides misleading airspeed data. Re- Relying solely on the calibrated airspeed at high speeds can lead to unsafe situations. Okay, so we have the drawing here, and then the marks are demarcations are very clear here, and then all measured in knots. The airspeed is measured in knots. So, in order to overcome this, introducing the Mach number or the science behind the supersonic flight. Mach number or MA is dimensional less quantity that represents the ratio of an object's speed to the speed of the sound in the surrounding air. At MA1, an object is traveling at the speed of sound, approximately 767 miles per hour at sea level. Objects exceeding MA1 are considered to be supersonic, while those below MA1 are called subsonic. So, Mach number is a measure that defines the speed with respect to the speed of sound. Now, they are instruments specifically designed to display the Mach number. They are often located on the instrument panel alongside with the airspeed indicator. These meters provide pilots with a more accurate representation of airspeed at high speeds and altitudes compared to the calibrated airspeed. The factors influencing the Mach number include the air temperature and the altitude. Air temperature, when warmer air leads to higher speed of sound, resulting in lower Mach number for the same true airspeed. Altitude, as altitude increases, the air becomes thinner and the speed of sound decreases. This causes a higher Mach number for the same true airspeed at higher altitudes. So we have to ensure that what is the air temperature and the altitude. The difference between Mach number and the true speed and the equivalent airspeed is given here. While all the three relate to the airspeed, they have distinct purposes. The true airspeed represents the actual speed of the aircraft relative to the air mass it is traversing, independent of the wind. Equivalent airspeed reflects the airspeed an aircraft would have at sea level under standard atmospheric conditions to produce the same dynamic pressure as at actual speed and altitude. The Mach number is a ratio of the aircraft's speed to the speed of the sound in the uh, air, of the surrounding air. The importance of Mach meters in transonic and subsonic flights. The transition between the subsonic or the Mach number less than Mach number and the supersonic, the Mach number above 1 flight is to be uh, understood as transonic flight regime. Airflow around the aircraft becomes highly unpredictable in transonic flight. Mach meters provide pilots with critical information to navigate this challenging flight regime safely. The supersonic flight, which exceeds the Mach number 1, where the aircraft travels faster than the speed of sound. Shock waves from around the aircraft during the supersonic flight, creating a sonic boom. Mach numbers are essential for pilots to monitor their speed and ensure that they stay within the safe operating limits for the supersonic flight. So with this, we will close this particular video, and we will meet again on another video. Thank you very much.